Hey, Adun.
Yes, hello. I welcome you, the members of the Uganda SWUG group, and to the many members who are coming in from the different countries around the world, joining together as SOLIDWORKS user group network to explore more as mechanical engineers, as engineers, innovators, and creators. So today I'm so delighted to host Yahya to take us through CSWP preparation tips. And I think this is the second time as Uganda SWUG we are hosting you. I'm so happy and delighted to host you because of the work we have been doing over the past years from the age of 16, from when we started using SolidWorks, and we became a champion and an expert below the age of 20. So we are so delighted to have you today and to share more knowledge on CSWP. So for the members who are in, the little I can speak about Yahya is a SolidWorks champion and an expert and also an advocate. So Yahya, the floor is yours. We are delighted to have you today.
Thanks for the amazing introduction. So, just as you just said, this session is all going to be mainly focused on the preparation for the CSWP or the professional level exam of SolidWorks. So before we start, let me just give a massive shout out to Edwin and for Uganda SWUG for preparing this session and making it possible. So let's get started. I think has already given a pretty nice introduction about me, so we can skip this about me slide. I hope most of you already know who I am, but if you don't, just a quick summary. I've been using SolidWorks for a bit over 10 years now, and what I'm trying to do now is to try and share my knowledge and expertise, specifically with the exams, as we're going to see it in today's session. Just a quick note, if you want to hear a bit more about my journey with SolidWorks, I was on another podcast from another SolidWorks user group leader, Prasad Adiga from India, and you can check out. We spent I think like an hour and a half or something just discussing SolidWorks and how I started to use it and stuff. So if you're interested in like learning a bit more about my background, you can check that out over here. Now let's get back to our topic for today, CSWP, right? So we're going to start by just discussing what the CSWP even is, because I would assume most of us might know what it is, but it's always good to reaffirm and to just do a check on what that exam is, who is it for, is it really suitable for me or not, and how would I even know if that is the right exam for me. We're also going to discuss a bit more in depth about the exam itself. What topics does it cover? What knowledge should I have before I take the exam? And the exam structure in general as well. And then we're going to share some tips and tricks regarding that exam, how you should approach solving the questions in the exam in a general view, of course. And then we might give some examples here and there along the way, just to make it easier for you to understand. And at the very end, we will showcase what it looks like to take an exam. Okay, and we'll also be sharing some free resources at the end that I've found pretty useful to me when I was taking those exams back in 2020, 2021-ish. Okay, so with that out of the way, let's get started. So let's start with what the exam is. What's the CSWP? And just like any other exam, the name of the exam is the title that you get when you receive that certification or when you pass the exam. So in this case, it's CSWP, Certified SolidWorks Professional. So that's what your title is going to be once you pass that exam. And a main thing here, which is the level of the exam. This is the professional level. There are multiple levels of exams, as you might already know. There's the associate level, which is usually for beginners. There's also the expert level for experts, and there's the professional level, which is like a mid-tier. But in my opinion, it's the one that most people should seek, because this is the highest level of exam that tests you in CAD design. Okay, and this is the second thing, which is there are many professional level exams. There's a professional level exam in simulation. There's a professional level exam in MBD, in API, in CAM, in flow simulation, and also in CAD design. So when you see just CSWP or CSWA or CSWE without anything after that, it's usually indicating that it's the CAD design exam or the mechanical design exam. Okay, and what that focuses on is the general aspect of creating parts, creating assemblies, creating drawings, and modifying those designs as you go through. Okay, so since we're talking about the professional level, which is higher than the associate level, this is mostly not just for a mere beginner for the software, it's actually for a well-rounded user, someone who has quite a good grasp of using SOLIDWORKS and on the different tools it has, as we're going to see in a moment. And the main thing here is that this exam is showcasing your skills, your expertise, your knowledge about the exam as well. And it's like benchmarking you at the other SOLIDWORKS users in the world. We now have like 8 million SOLIDWORKS users, but we only have like 250,000 certified professionals. Okay, so that sets the standard for you as where you are, where you stand in the world. And this is all just for you better showcase yourself and get a better chance to present yourself at an interview or to an employer to get an internship or to get a job later on. Okay, just a quick way to say, okay, I've got skills that are proven by this exam and this certification to at least this level. Okay, and if we take the description of what he is on the website itself, it says that every CSWP has proven their ability to design, obviously, because this is once again a CAD design exam. And the other thing, which is to analyze parametric parts and assemblies, and this is what we're going to talk about in a moment. It's not just for parts and assemblies and different modifications to these designs as well. But the thing here is it mentions movable assemblies, which even showcases how important it is to work with correctly mated assemblies together, not just adding components and building them up, but also how they would move in a correct way as the design intent would require you to. And it ends up with the description of how they would reach that level through the various tools and the features that are in SOLIDWORKS. So I've highlighted a couple of words here, and these are the words that I want you to think about and to consider. These are the highlights or the keywords that that the CSWP is specifically targeting, as opposed to just the CSWA, which is for mere beginners, as we mentioned earlier. Okay, so the main resource I always go to when it comes to any exam is the main web page for that exam. So if you go to solidworks.com/certification and you search for that exam, let's say, for example, in this case, the CSWP, so you're going to find a whole list of all the different exams that SOLIDWORKS offers. I think there's up to like 29 or something by now. So you can go and click the exam information button for the CSWP, and you will be presented with this web page. So if you scroll a bit down in that web page, you're going to find a bit more information about that exam. So it starts by like what the exam is for, how long it is, which is the like the oldest version of SOLIDWORKS that you should use to take that exam. So I'm pretty much sure that nobody here uses 2015. Obviously, everyone is using a newer version, but just in case, these are the prerequisites, the things that you should take into consideration before taking the exam. And it also mentions the sample exam over here, okay, which we're going to get back to a bit at the end. But remember, if you want to get the sample exam, the simpler version of the exam to test yourself, you can get it from the certification website itself. And if you scroll a bit down, it tells you a bit more about the different segments of this exam, because this exam is a bit different from other exams. All exams are just in one go. You start the exam, it's like an hour and a half, 2 hours, 3 hours, 4 hours, no matter how long it is, you just take the whole exam in one go. But the CSWP is a bit different because by default, it's actually divided into 3 segments or 3 parts. every part is totally separate from the other parts. You can take each one of them on its own. You don't have to take them in order. If you pass one of them, that doesn't affect the other. If you fail one of them, that doesn't affect the rest, and so on. And once you pass all three segments, you receive your certification. So if I'm not mistaken, I took the second segment, then the third, then the first, something like that. I didn't take them in order, and that's just fine. But each segment has its own duration, it has its own topics, it's got its own data set, and you take it in one go. And then when you finish that segment, that's much it. You get your notification if you passed or failed, but you only get the certificate itself when you pass all three segments. Okay? So if you scroll a bit down, you're going to find every segment, what it includes, how long it is, stuff like that. But the main thing here is an exam info part. When you scroll all the way down, you find a list of features that this exam covers. So these are not just features, but commands, topics, industry topics that you should be interested in, and also proficient in. Because here's the thing, these exams, once again, they are hands-on exams. You don't just take some multiple choice questions and answer them. You have to start the software and start answering and designing these parts to be able to solve the exam. So not just knowledge about these topics, but you also have to be proficient in them. You need to have your hands-on experience with them. So go through this list, go through these features, and make sure that you're familiar with all of these. You've used them before in your projects. And if there's anything of these different features or commands that you're not familiar with, or that you haven't used before, for example, configurations maybe, or replacing components in assemblies, stuff like that, make sure before you take the exam to look up that new command, to start using it in your day-to-day designs. And then once you get proficient in it, then you can go ahead and take the exam. Okay? So once again, make sure you go through this whole list, because the exam is going to test you in all of these, not just some of them, all of them. Okay, so it's really important to make sure that you understand all of these topics very well and you have hands-on experience with them before you take the exam. Okay, so now let's take them one segment at a time. Let's start with the first segment, and this first segment is mainly about part modeling and then modification, making some edits to that design that you create. So let's with the modeling section. And when we talk about it, let's take it in steps. What should you do first, and then what the next steps should be. So the first thing is you get your questions, and you should read the questions very well. And the questions are presented to you in this form. You have this interface. On the left, you will find the question itself in text. So do this, do that. Here's the parameters that you would need, and so on. At the bottom, you will find the time bar, which tells you how much time is left. You find the next question button, the right question button. They're always available, by the way. So nothing prevents you from just scrolling through the whole exam or through the whole segment and just checking what it would require from you to do later on, to take that into consideration while designing in the very first place. So maybe before I start my design, I look, okay, what's the second question going to ask me to do? What's the third question talking about? And understand all of these so that it's easier for me to design the very first part, okay? You also find the upper right corner where you've got the different images to help you. These might be drawing views, section views, different types of views, which would mostly include dimensions and notes and annotations and stuff like that. But there's one thing to remember here, is that your very first answer is going to be a multiple choice answer. As you can see here, you've got 4 different choices to select one of them. So the thing is, you must make sure that your answer is exactly one of these 4 choices. So it might be a bit close, but that's not enough here. Because if it was enough in this question, so let's say, for example, the 4 different answers are 10, 20, 30, and 40. And your design, when you create the answer you got from SolidWorks was 11. So you might say, okay, it looks like 10, let's choose 10. That might sound okay right now, but in the next question, when it asks you to do some modifications or some changes to the design, it's not going to give you multiple choices. It's going to give you a text box to enter the value. And remember, if your answer is not exactly the right answer, well, you still have like 0.5% as leeway or error percentage to work with. So if your answer is not within that 0.5% window, it's a wrong answer. So make sure that your very first question is exactly how it should be, one of those four choices, so that when you change it or modify it later on, when you build on that base design, you make sure that those build-up layers are correct, and therefore your answer has a higher chance of being correct as well. Okay? So this is the first thing. Once again, feel free to go through the different questions before answering. Feel free to take your time to go through the different images and read the whole text. Make sure you understand it well. And the main thing is, when you come to answer the first question, make sure it's exactly one of the four choices that you're presented with. Okay? So let's take it to the next level. Some of us will just stop SOLIDWORKS, create a new design, and just start sketching and creating the model. That's not wrong, but this is something that I've personally been a victim of, which is to forget to set the correct units. Okay, so in some questions it might tell you to create it in inches, in other questions it might ask you to do it in centimeters or millimeters, and so on. So it's really important before you start creating your very first sketch to make sure that you've got the units correct, because the thing here is, if you create the sketch, let's say for example you create a square, and that square is 10 millimeters by 10 millimeters. If you realize later on that it should be in inches, 10 inches by 10 inches, if you go down to the bottom right corner in the status bar and then change the units from millimeters to inches, it's not going to change the units just like that. It's going to actually convert the units. So it's going to say, okay, 1 inch is like 2.5 centimeters. So it's going to do the conversion. So you're not going to end up with 10 inches. You're going to end up with whatever that value is in inches. It's going to be converted. So you'll have to go back again and then change your dimensions, or use the scale tool to scale the feature up or down. But that also means that your dimensions are not exactly how they should be in the design. So it's really a good practice to start slow, take your time to specify the units before you start doing anything, doing any sketches or anything. And some people actually take this to the next level and create part templates and assembly templates with the different units ready. So when you create new, you can be presented with, do you want to create this part template, use this part template, or this assembly template, or this drawing template? They would actually create multiple part templates, multiple assembly templates, and so on. One for inches, one for millimeters, and so on. So it's like just a quicker method of selecting the units just while creating the parts. Okay, it's totally fine to do it either way, but the main thing here is make sure you select the units before you start designing or doing any sketching. Okay, so now let's take it to the next step, which is variables. So usually in the exam, you would find some dimensions missing, and those dimensions will be replaced with a letter, with a variable. It may be X, Y, Z, A, B, C, and so on. And you would find the value of those values of these global variables in the question itself, in the text. So it would tell you, hey, X is 10, Y is X divided by 2, and so on. So one way to do it is to just replace this in your mind and go ahead and just anywhere where it says X, just enter 10. Anywhere it says Y, just enter 10 divided by 2, which is 5, and so on. So that's fine. But the thing is, later on, when it tells you to modify X or modify Y, are you sure you remember every single place you used X in and Y in to replace it? Or the other thing is it going to be easier or faster for you to go ahead and do it for every single instance? Or is it going to be easier to set it in one place, which is in the equations dialog box, and just modify it later on in that one place? And the moment you hit rebuild or OK, it's going to automatically update the whole model, which is quicker. Obviously this one, right? So this is the better way to go with it. So take your time to specify all of these at the beginning. Some might like to do it as they go, as they design. So when they need to add the dimension of 10, which is actually going to be called X, they would enter or create that global variable while they are entering the dimension. That's fine. I prefer making sure that I've got everything ready just to make sure that I don't forget anything. So I start by setting up all of my different global variables, and then I go to design. In that way, when I start adding my dimensions, I can immediately reference those global variables that I've already created. Okay, either way, it's totally fine. This way is fine, that way is fine. go with whichever method you prefer. But if you want to have like a checklist in your mind, okay, I've set the units, I've set the global variables, now I can start design. That's the way I would prefer, just to make sure that you don't forget anything. And while you can now start going by your design strategy and start creating your sketches and everything, now is also a good place if you're also going to go with this checklist strategy to add your materials. So even though the material itself is not going to affect the design right now, so whether you add the material at the beginning or add the material at the end, it's not really going to make much of a difference. But it's always good to make sure that you're not missing anything, because we've all heard the stories about someone who created the design, which is 100% correct in terms of dimensions and choice of design intent and features and everything, but they forgot to assign the material, or they assigned the wrong material, so they end up with the wrong answers. Okay, so make sure if you're also going with the checklist strategy, I've set the units, I've set the global variables. Also, it's a good time now to set the material as well. And now, finally, you can start by creating your very first sketch. And when it comes to sketches, there's one main thing that you should do, which is to make sure that all of your sketches are fully defined. As Tool used to say, fully define every time. Okay, and there are like multiple ways to figure out if your sketches are fully defined or not. Okay, but let's take a step back and say why it should be fully defined. By the way, if you know any easy ways other than this one on screen right now to figure out if your sketch is fully defined or not, please let me know in the chat. But while you go ahead and do that, let me tell you that if you have a sketch that is under-defined, it's not fully defined, that means that if you do some changes in the future, if you edit a dimension value, if you change the value of a global variable, and so on, you're more prone to errors. You're more prone to the sketch changing in a way that you don't want it to change in that way. So you might want it to change in a certain way, but because it's underdefined, it doesn't understand your design intent. So therefore, it has multiple choices, multiple options to go through, and it would just choose whichever is easier for the software, right? So it's not 100% going to change in the way you think it's going to change as. So that's why it's really important to make sure that everything is fully defined, so that when you change, you don't get any errors. Everything is just perfect because you've already set the intelligence correctly in that design. So let's get back again and see how we can easily identify if the sketch is fully defined or not. So as you can see right in the bottom right corner over there, also in the status bar, you can see it says underdefined. But that's only why I'm editing a sketch. So if I exit the sketch, it's not going to show me anything. It's only why I'm in the sketch edit mode. It's going to tell me, okay, right now I'm editing sketch 2. So it's telling me that this sketch is underdefined. I can quickly glance at the bottom right corner and see in the status bar if it's overdefined, underdefined, or fully defined. So this is one way. Another way is from the feature manager design tree itself, which is usually on the left side of the screen, but right now it's on the right. Anyways, can you see the difference between sketch 1 and sketch 2? So the only difference here is that sketch 1 is fully defined and sketch 2 is underdefined. And we know that just by looking by the symbol that precedes the second sketch. You know, these two brackets with a minus symbol in between, that indicates that it's underdefined. Okay. And by the way, just as a pro tip, if it was a plus sign, that would be an over-defined sketch. You've defined more than SOLIDWORKS is. Okay. So once again, once you glance at the feature manager design tree or at the status bar right at the down bottom right corner, and you see this minus sign or the underdefined symbol, that means that this sketch is missing some dimensions or missing some relations, sketch relations. That means that if you modify the sketch, it might not change in the way you expect it to. Okay, so I sometimes actually do this. I go by and count how many dimensions are in the question. So let's say I've got a drawing view. I'll count the number of dimensions and then count the number of dimensions I have inside of SOLIDWORKS and make sure I've got all of them right. This is the way that works for me. Maybe it would work for you. Whichever way you prefer, just make sure that your sketches are fully defined. You have defined them through relations. If relations are not enough, then you would go to add dimensions. If dimensions are not enough with relations, then maybe you should add some construction geometry just to make sure everything is set up correctly. Totally up to you, but whichever way you go, make sure that your sketches are fully defined. That's the main goal, right? So okay, we've got the sketches fully defined. We've got everything ready. Now let's go ahead and create our features. So now what you should do is just take a deep breath and take your time to think about which is the best course of action to design this model. So you've already created the first sketch, which means that you've already given it some thought. Am I going to start on the top plane? Am I going to start on the right plane? Maybe on the front plane? Which is the best one? But the next thing, which is which features am I going to use? And when you select the feature or you decide which feature you're going to use, which contours or which regions am I going to extrude or to revolve or to sweep or whatever it is, and what value am I going to use, and so on. So make sure you break all of this down in your head mentally, and then think of which is the best way or the best course of action to design this with respect to the next steps, which is the modifications that you would create. Remember, at the very first part of our session, we mentioned to go through the whole exam and to understand what modifications it would later on require from you. Well, this is the thing. This is the best time to understand that if I create it in a certain way right now and then modify it in the future, is that modify easy? Just a simple changing of a dimension or a changing of a feature or a value, or is it going to be tedious when I need to add more features or remove some existing features and so on? So the easier you make it for yourself, the easier it is for you to solve the exam, and the more calmer you are while taking the exam. So it's really important to take that into consideration, to consider how you would approach design. I see someone mentioning adjusting the volume. Please let me know if the volume is fine. He didn't mention if it's too low or too high. If the volume is fine for you, just let me know in the chat. Maybe like a +1. Okay. Let's see. It's too low. Okay. Let me try and increase my audio. Okay, so yeah, car passing sounds. I will add noise cancellation. I've just activated it, and let me see if that makes it any better for you guys with the background noise. Okay, so let's get back to what we mentioned last. We went through the questions to understand what is the best course of action to go through this design. We also looked at the checklist. Have I set the units? Have I set the material? Have I set the global variables, and so on? And then we created our sketch, made sure that everything is fully defined, and then at the very end, we started by creating the features and creating the model at the end. Okay, so what's the next step? Well, the next step is always going to be to answer the question and then go to the next question and keep going through those questions. But let's take a quick break and take this example and try to design it with ourselves. It's very simple, by the way, and make sure that whatever exam question you would find is going to be way more detailed than this example that I've created for you. Okay, so let's just give it a bit of a thought. It says here to create a 100 by 100 by 20 block with a 15 millimeter in diameter through hole, and that through hole is located at the third of the block's width and the fifth of its height. Okay, and obviously the units are mmgs, millimeters, grams, and seconds. So let's design this together. But once again, this is like a very simple example, but I'm just trying to show you how I would go about this. So I've got here SOLIDWORKS open already. Let's start. So I'm going to create my first sketch, maybe on the front plane, and I already have been using SOLIDWORKS for quite a while. That I'm now familiar with what the features do and where they are and stuff like that. And I've also added some keyboard shortcuts to my settings so that it's quicker for me to design. So I don't have to go and select a rectangle or go and search for it or anything. I can just simply press on a button on my keyboard and then go straight ahead and use that feature. Okay, so this is just a pro tip for you. If you want to be a faster designer, start adding these customizations. It can be adding buttons to the S key, to the shortcut bar. It can be adding keyboard shortcuts, mouse gestures, whichever works for you. Make sure to try and make yourself a better, more productive designer. Okay, so I'm using SOLIDWORKS 2025, the latest edition. And there's a very neat enhancement here, which is if I want to create a square to have an equal relation between both edges, I can simply hit Shift on my keyboard, and as you can see, it's already a square. Okay, so I'm going to do that, and then the Smart Dimension tool, I also have another keyboard shortcut for that. So as you can see, the icon right next to the cursor, I've already switched to the Smart Dimension without having to move and select Smart Dimension or anything. And I can now enter the dimension of, so it was 100 by 100. Okay, let me just make sure that I've got. So I've just added my sketch relations. I prefer working with sketch relations visible, just to make sure that everything is available right in front of me, and I understand how the design is changing. So I've got this. Now let's go and create the through hole. So let's just create it in the same sketch, okay? And I've also got another keyboard shortcut, the circle. So I'm just going to change to the circle. As you can see, also the mouse cursor has changed as well. So I'm going to add my circle maybe over here, and that, if I'm not mistaken, it was 15. So that's N15. And now the next step is to identify where that circle is supposed to be, because it's still underdefined, as you can see over here. I can still move that circle around. So it was the third of the width and the fifth of the height, right? So there are multiple ways to do this. Let's go with the dimension. So if I select this dimension, okay, and I want it to be this 100 divided by 3, right? I can just select the 100 and then say I want it to be divided by 3. And just like that, it's now going to be 33.33, which is correct. But here's the thing. What if this 100 changed later on? Maybe we change it to 150. You see, that 33 did not update, okay? And the thing is, the question didn't say put it at 33 millimeters from the side. It said put it at the third of the side. So if the side increases or decreases, this should also follow it as well, right? So the thing here is I didn't add an equation for this value. So what I did is, let me double click and change it once again. I simply selected, which just copied that value and put it in the dimension box, and then I said divided by 3. But notice the correct way to do it is to start an equation by the equal sign. So I'm just going to click equals, and then now when I select this, then you see it didn't write 150. It says dimension 1 at this sketch. So it's now referencing the whole dimension. And now I can do the same thing divided by 3. But now, see, I've got this sigma sign over here. This sigma sign tells me that this is an equation, okay? And the other thing is, if I change this to 100, well, it's also going to update with it, okay? So now I've made sure that these two dimensions are linked together. There's an equation between them. So when this changes, that's also going to change as well, okay? So let's do the same thing with the vertical distance. So I want it to be the fifth of the height, okay? So let's say, for example, I want to do it in a different way. Instead of doing it with dimensions, what other ways could we use to do something like this? Maybe let's do it with reference geometry. Because I prefer using reference geometry, in some cases it's actually the better way to do it. So I'm not sure if any of you have heard of the tool called the segment tool inside of SOLIDWORKS. If I'm not mistaken, it's been around since 2015 or something. It's a pretty old feature in SOLIDWORKS, but not many people use it. So the segment tool, what it pretty much does is that it creates equal sized segments of whichever sketch entity that you give it. It can be a line, it can be an arc, it can be a circle, a spline, whatever it is, it's going to divide it into equal segments, okay? So let's say, for example, I draw a line over here, and I've already launched my center line command from the keyboard shortcut. So as you can see, I've got my center line. Now, when I select this center line and go to the segment tool, I'm not sure where it is, so I can search for it over here in this search bar. And if I click on this I symbol, this show command location, it's going to direct me to where that location is. So it's pretty much going to come over here to file tools, sketch tools, and then it's going to go over to segments. Okay, but since I use the segment tool a lot, I've already added it over here to my command manager because this is quicker for me to access it. So I'm going to launch it from here. I'm going to do it on this line, and as you can see, there are two options. I can either do it by point, or by segments. So let's do it by segments, because that means that I'm going to actually divide this line into 5 different lines. I'm going to like delete the old line and have 5 different lines in place or in its position. Okay, so that looks good. Let's hit OK. And now all I have to do is just make sure that this point and that point is the same. So I'm just going to add a coincident relation, and just like that, as you can see, my sketch is fully defined. Okay, it's all looking good. It says fully defined over here. Now I can exit my sketch, and what's this? For some reason, when I exited that sketch, it took me directly to the boss extrusion command. Do you know why? And this is one of the things that I mentioned. Knowing how the software works is going to make you a better designer, a quicker and faster designer, a more efficient designer. So let me see. Does anyone know why? Let me know in the chat why when I exited the sketch, it automatically went to a command. I didn't specify boss extrusion. I just clicked exit sketch. For some reason, it just went to boss extrusion. The S key. No, I did not click on the S key, because when I click on the S key, so let me just go back again. Now in the sketch, when I click on the S key, it's going to show you something like this. You're going to see the whole shortcut bar, and I don't even think that I've got my boss extrusion over here because I don't really use it that much. So no, what I did is when I clicked exit sketch, it for some reason went and created a boss extrusion. Does anyone else know? Abdullah is saying started using a boss extrude rather than sketch. Exactly. So this is the thing. When I started by creating that first sketch, I didn't go and click sketch and then select the plane. I clicked on boss extrusion. So what that meant is that SOLIDWORKS is now asking me to select a sketch or create a sketch. Since I didn't have any sketches already created, when I clicked on that plane, it now launched the sketch mode to create the sketch. But it still remembers that you came here looking for a boss extrusion. So therefore, when you exit the sketch, it's also going to take you back to that boss extrusion you wanted to create in the first place. So that's why when I clicked exit sketch, I didn't have to do multiple clicks and go to the features tab and launch extruded boss. It automatically went to the extruded boss because I started by selecting that feature, not by selecting a sketch command. Okay. Okay, someone wants me to show it again. That's fine. Let me just cancel this. Let me also exit this sketch. And let me do it once again. So instead of clicking sketch, if I click sketch, it's going to tell me, okay, sketch, it needs a plane or it needs a face. So let's select that. But what I'm going to do is I'm going to select the extrusion. Okay, I'm going to click on extrude. It now tells me you either select a sketch or select a plane. And this is what I did. What I did is that I went ahead and selected the plane. Let's do it on the right plane, for example. So right now I'm inside of the sketch mode, right? I'm in a sketch. I can do anything, maybe like a circle over here. Okay. And now when I exit the sketch, notice I'm going to click exit sketch, but it remembers that I came from the boss extrusion. So it's now going to take me back again to the boss extrusion. Okay, Tanvir, is it now a bit more obvious that you don't have to do multiple clicks? It's all about knowing how the software works and taking that into consideration while you're going ahead. Okay, so now let's get back again to our previous one. Let me just delete that sketch. We don't need that anymore. Let me see. Okay, so now let's go to this sketch and do our boss extrusion. Let me remember. I think it was like what, 20? I think it was 20 in terms of extrusion. So there it is. And just like that, now we have our design completed. So now let's check the mass of this design. Now, obviously, a real exam question is going to ask you to specify a material, okay? But because once again, this is like a simple example, you can just neglect this for now. But once again, in a real exam, it's not going to just out specifying a material. So since I'm also going to be required to now see the mass, I'm going to show you how to calculate that later on. But right now, I already have a keyboard shortcut just for that. So it says that here the mass is 196.47 grams. And let me also paste that into the chat just to make sure that I don't cheat. And now let's go back again inside of the presentation and see what the right value is supposed to be. So it looks like the value is indeed 196.47 grams. Looks like I'm ready to be a certified professional. Just kidding. So once again, this is how I would think about going through a design like this. You know, I started by thinking, okay, which features am I going to use? Am I going to do a boss extrusion? Okay, I need a sketch. I'm not going to go directly to the sketch. I'm going to start by the boss extrusion and then select design the sketch. How is the sketch going to look like? I said, okay, let's do it with a rectangle and so on. But the rectangle, it needs to be equal sides. So instead of doing it by two different dimensions, I opted to do it as a square with the new enhancement in 2025, hitting the shift button. And then I also said, okay, why not save myself a couple of features instead of doing like the extrusion in one feature and then the cut in a separate feature. I just said, okay, let's do them both in the same feature. Okay, so different things that went through my mind, and I'm pretty much sure that the result is the same regardless of how I did it. It's all about how fast did I do it, and the other thing is how easily can you edit or modify this, which is going to take us to our next point. Okay, the next part of this segment is to perform some modifications. And modifications, as I mentioned, they can come in two different flavors. The first one is just simply changing the value of a global dimension. So let's say, for example, if we go back again to SolidWorks, remember this 100 dimension. Instead of it being 100, if I create a global variable for this, I can say equals A, okay? And then SolidWorks is going to say, okay, do you want to create a new global variable with that name? I'm going to say yes. Okay, so now if I click on this toggle, it says, okay, this is equal A and A equals 100. Okay, and now I'm also going to have over here the equations dialog box, which shows me everything. So if I go and manage my equations, now I've got A equals 100. I can do it the other way around. I can start by creating A and then go and reference A in my sketches or my dimensions. That's totally fine. And by the way, actually, I'm going to do that right now. So if I go and modify that sketch once again, remember this dimension, this 33. So it's actually referencing the dimension, and the dimension is referencing A. Why not just make it reference A directly? So I can modify this to say, okay, equals A divided by 3. Pretty simple, right? And it's going to be the same value because A equals that dimension. But now if I go back again, the design didn't change. If I check the equations, it's now going to be all referencing A. So this dimension is A, and this dimension is A divided by 3. Okay, so just like that. But the power of this is if I changed A to, let's say, 125, okay, and I hit enter, as you can see, the model has changed and the dimension of this, the placement of this hole has also updated. So everything can be changed from one place. I don't have to go and search, okay, I used A here, I used A there. Everything can be updated from one single location, okay? So this is pretty much the easiest way to do some modifications. You have a list of global variables, all you have to do is just go through that list and start modifying them. The other way is to do some real changes, to add features, to remove features, to suppress some features, and so on. Maybe add a fillet here, add a chamfer here, add some holes here, add some ribs or counterbore holes or whatever it might be. But this is going to require a bit more thought, a bit more understanding of how you created the design in the first place, how the modifications should be added to that design. And this all comes down to, did you create the design in the beginning in an easy way or not? And easy has many definitions. It can be easy in terms of it's very quick to design. It can be easy in terms of it doesn't take much computation time. It rebuilds quickly. It can be easy in terms of you're not using any niche features, any strange unknown features. It's all sketches and dimensions and extrusions, no segment, no strange features that people haven't heard of. And it can be different things. But what I would identify easy as in this case is it's easy to edit with the minimum time and effort required. So if you need to change something, it doesn't take you 10 steps. It only takes 1 or 2 steps maximum. And that means that you've created it with the correct design intent in mind. And once again, we're mentioning design intent. So I think it's worth to take a moment and talk about design intent, which we're going to come to in a bit. But once again, the whole premise here is, have you designed the whole part in a way that is easy for you to modify it later on based on what the question wants you to do, not on what you would like. Because right now we're doing a design based on external information, right? So if the change that is required from me is to change a dimension, and I go ahead and I change that dimension, but I end up with many errors, that means that my first design, my first step, my first question, even though I might have finished it in 1 minute, but it wasn't worth it, because now I have to spend another 10 minutes troubleshooting and figuring out what went wrong and so on. But if I spent like 3, 4, 5, 15 minutes making sure that my very first design is perfect, and every modification later on just takes 1 minute or 2 minutes for me, now that's an easy design. Now that's a correct design in terms of design intent and modification. Okay, so now let's see what modifications we can apply to the design we just created. Now it says, okay, make it 150 by 200 by 30, and change the hole from 15 to 20 in terms of diameter. And instead of being a through hole, now make it 10 millimeters in depth. And the placement of it used to be a third and a fifth. It's now going to be a fourth of the width and a fourth of the height. So many different modifications to do here. Let's take them one by one. Okay, so now let's get back again inside of SolidWorks. Okay, let's see. Okay, so what I would like to do now is start by mentioning something. Because I didn't look at the whole sequence of questions, I didn't look at the second question before I started by designing the first question. Now I figure out that I've done something wrong, because it should be as easy as just clicking on this, highlighting it, and because I have instant 3D enabled, I can see all of these dimensions. I can immediately just click on one of these, enter the dimension, modify it, and call it a day, right? But the thing is here, if I take this back again to what it used to be, so I'm going to call this 100. I'm going to call this also, actually, I don't think I need A anymore. So you know what, let's take a step back. Let's go to this sketch and go back again to what I designed it as previously. So here, I don't need this equation anymore. I'm just going to say it's 100, right? And this value over here, I don't need it to be linked to A anymore. I'm not going to use A right now. I'm going to leave it as it used to be, just like that, okay? But there's another issue here, because now, even though I'm not using A, all I had to do, if I'm using instant 3D, you see, this feature is an amazing feature. It's like a godsend, really, because what it means is that all I have to do to do some modification is simply click on any of the faces of that feature, and it highlights everything like that, and then I can do a single click on this 100 and change it to 200, like that, right? But the thing is, it should be that easy to do the same thing with the 150 in terms of height, right? Because it wants to be 200 by 150. But because I created this with the shift key, that adds a relation between those two edges. And relations can't be edited by 3D. I can change any dimension. I can change this 15 to 25. I can do all of that. I can change this 20 to be 30, the extrusion itself. That's fine. But what I can't change is change a relation outside. So I'm now obligated to go ahead and change or modify that sketch. Okay, so this is something to take into consideration. If I had read the whole questions beforehand, I would say, instead of doing this with an equal relation, as you can see over here, I would actually do it even in the first question as a square with 100 dimension and 100 dimension here, to make it easier to modify in the future. Okay, someone is asking, can turn on 3D? Simply search for instant 3D and just click on it, just like that. Now it's off, and if I go ahead and click on it once again, now it's on. Yeah, you might also in the features tab over here, but I prefer to remove it. You also have instant 2D, which will do the same thing for sketches. I prefer to have them on, but it's obviously a personal preference. Okay, so now let's go ahead and now fully define this by 150. Okay, and now we've got this part ready. Now what's missing is the placement. So this is going to be pretty simple. I can just double click on it. Instead of divided by 3, divided by 4, right? and now it's exactly how I would be. But because I was trying to show off my skills with the segment tool, let me just hide these relations for a moment. I've got all of these different segments, and I now need to update this. Instead of being 4 times, I need it to be 5 times. Now, maybe, let's see, what relations does this add? It adds equal relations, collinear relations. It's not, there's no pattern relation to update or modify. It's not like a sketch pattern or something. So maybe let's say I delete one of these to make them 4 instead of 5, and drag these to be, okay, it's acting up. Let's add like a relation, reason giving me an error. Okay, I'm going to save you some time and say, okay, the easiest way to do this is to delete the very last one, and then just simply drag this all the way down, right? So now it's correct, but for some reason it was giving me errors, and I didn't want to bother myself by looking into why I had that error and figuring it out and troubleshooting or everything. But by the way, there was a very easy way that would have saved me a lot of time if I had done it a bit differently. So let's say, for example, I do the same thing. I now have my center line, as you can see over here, okay? And I'm also going to use this segment tool, but instead of doing it with the sketch segments, I'm actually going to do it with the sketch points, right? If I select 5 points, but I only need 4 points to divide it into 5 segments. So now I make it only 4. Now, as you can see over here, it's going to be only 1 segment, 2 segments, 3 segments, 4 segments, and 5 segments, just as I want, but with only 4 points. And if I hit OK, I can also do another circle of this one. Let's just add it over here, like that. Maybe make these 2 equal, whatever. But the main thing here is this. You see this relation? Now I have a pattern relation that I can update later on. So I can right click on it and I can say, okay, edit segment. If I do that, I can change it from 4 to 3 and I'm going to update just like that. And there's actually another way, because since this is like a pattern, if I delete one of these points, it's automatically going to rearrange itself. So now if I delete one more, it's going to be at a third and so on. So it's automatically updating. So if I had given myself a bit more thought into which design strategy I would use, it would save me a lot of hassle and a lot of troubleshooting and errors and stuff like that. So it all comes down to, once again, choosing the right tools to create the design. You can do this design in multiple ways, but it all comes down to, is this the best way or not? Okay, so now let's just delete all of this. And now that we've got it to be the 4th of the width and the 4th of the height, there's one more thing. So the thing is, now this is the through all hole. And what I wanted to do is to only have like a 10 millimeter depth, right? But because this is all in one feature, I now have to modify the feature as well and to deselect it and do it in a separate sketch or in a separate feature, at least. So it also, once again, had I known this from the beginning, I would have opted to do it as 2 features from the get-go, just to make it easier to modify and update later on, because it takes time to go ahead and edit the feature and create a new feature and so on, where we've simply done this like with a simple whole feature or in 2 separate sketches and so on. Anyways, let me just clear this selection, choose the circle, and like 10 millimeters, as you can see, and just like that, now we've got the design ready, right? So now let's see the mass. It's going to be this value. I'm not sure if this is entirely correct or not. Maybe I've missed a bunch of dimensions over here. Let me just check real quick. Just a moment. My device seems to be acting up. Okay, so it was 150 by 200 by 30. It was 20 by 10. Okay, 20, not 25. Okay, let's get back again to SOLIDWORKS. So this is 20. Yeah. Perfect, because now if we check, yes, this is the correct mass. So it's going to this value. Let me also put this in the chat real quick. Okay, and now if I check, it is indeed 896.86 grams. as if I didn't do it in 2 takes. Just disregard that. But anyways, so there's a couple of things to understand from from my mistakes right now. The first thing is I didn't look ahead. I didn't understand what the modifications are going to look like, and therefore I created the design in not the best way possible. There were better ways to create this design, as we saw. There's also the other issue, which is I decided to do everything in one sketch and do everything in one feature because that's quicker, but that was actually taking me more time to modify it in the second stage. So if I had taken some time to make sure that everything is set up correctly in its own feature, maybe in the first stage, that would have made it using instant 3D very easy to just highlight, change the value, highlight, change the value, without modifying any sketches, without modifying any features, everything just from the outside, you know? So that would be a much bigger time saver in terms of the design. But at the end of the day, we still ended up with the same 3D geometry. It's all about how we reached there, how we approached there, okay? So I hope this was enlightening to you. I hope you got a couple of tips and tricks as we went, because now let's take it to the next stage, to segment 2. And segment 2 is mainly going to be talking about something slightly different from what segment 1 is about. Segment 1 is about creating a sketch, creating a feature, creating a couple of features, modifying those features, and so on. Segment 2, it's more about configurations and design tables. So you already have you're presented with a design. The exam will give you a model to download, and then you would change that design in terms of how the question is going to tell you. So the thing here is you need to understand how that model was created in the first place to be able to modify it yourself, because you didn't design that model, someone else did, but you now need to modify it. So you need to understand what he was thinking of when he created it in the first place. Why did he create this sketch? Why did he use that feature? Why did he do it in this way? And based on that, you will be able to later on modify that design and do the modifications that the exam asks you to do. Okay, so there are a couple of things that you need to take into consideration here. The first thing is design intent. I mean, I think that's a given, right? So far we've mentioned design intent a lot, but once again, this is the pinnacle of when you should use design intent and when you should apply it to your designs. If you don't understand the design intent of the models that you were given, you won't be able to modify them in the correct or easiest way. So the second thing you need to understand is also design intent. And after you fully understand design intent and design intent, we can now go to the next stage, which is also design intent, and then we can learn a bit more about design intent and finish by design intent. And if we still have some time, maybe look at some other topics like maybe design intent, design intent, design intent, and design intent. Let's get back to reality here, because this whole segment is all about understanding someone else's design and doing the modifications yourself. And this is all about design intent. So what is design intent? Because I've been saying this word a lot today. So as it says, design intent, understanding the intent of the design. Why was this design created in this way? Okay, once you understand why the design was created in a certain way, it would be very easy for you to understand which is the easiest way to modify it, to change it, and to update that later on. Whether that was by direct modifying, or maybe through the equations, or maybe even through the configurations that you will create later on. But this is all based on understanding at the very beginning how that model or how that part or whatever it may be was created, what was going through the mind of the designer who sat down and created those features. Okay, because this is the end result. If you don't understand the design intent, and some other community members mentioned, this is the ketchup and mustard that you would not like to have alongside your order. Nobody likes to have this whole list of red and yellow errors and warning and so on, because this might be as simple as just doing one modification and ending the long list of errors that you now need to troubleshoot and figure out what went wrong with them. But you would save yourself all this time and effort if you understand how that design was created in the first place, and therefore you would make it very, very easy for you to change it according to those guidelines that design was created with. Okay, so there are a couple of tools that would make it easy for you to understand something like this. Best of them is the child and parent relationships, understanding what affects what. If I change this feature, what else is going to change? If I modify this feature, what else is going to be modified? If I delete this feature, what else is going to be affected? And understanding this is called the child and parent relationships. So if a feature depends on a sketch, okay, so that sketch is now the parent and the feature is the child. And if that feature, when it's modified, it also affects another feature, so that feature is now the parent, and the other feature that is updated as well is now the new child. So as you can see, one might be the parent of one thing, but the child of another thing. Okay, so this whole relationship between the different features and sketches and planes and references and all of that is really important for you to understand, so that when you change one thing, you already know that as soon as I hit OK, this is going to change and that is going to change and this is going to update and so on, because you already understand what is linked to what affects what, who is the child and who is the parent. Okay, so if you right click on any of these features and go to the child and parent relationships, it's going to tell you, okay, so here, for example, you have that revolve to is the parent, and it lists the children for that for that feature as well. So you now know that if you modify one of these features, these are the features that will be affected alongside it, so on. And remember, this can be anything. It can be a sketch, it can be a reference geometry, like an axis or a plane or any of those things, but it all comes down to what changes what or what affects what. So if you go back again inside of SolidWorks in action, so here's our design. If I right click on any, let's say this sketch, okay, over here I can see the child and parent. If I click on that, it's now going to that this sketch, its parents are the origin and the front plane, because this sketch is created on the front plane and it references the origin. Okay, its children are that boss extrusion and this cut extrusion, because these are what were created from it. So if I change any of these, and if I change this, these will be changed. Okay, so once you understand what affects, it's really easy for you to say, okay, now if I change this, I would expect this or that or both of them to update as well. Okay, but there's actually a pretty neat way to visualize these in a format. So instead of going by and right clicking on everything and just say which is the parent, which is the relation, which is the child, and so on, you can simply see, oops, nope, not right now. We still have some more to go through. Let's get back on track. Yep, over here. Yeah. So here, this is the other way to visualize it in a visual way. As you can see, we use arrows that would indicate if it's the blue arrow going upwards, that's the parent. If it's a purple arrow, as you can see over here, going downwards, that's the child. And the very easy way to visualize something like this is a setting in SolidWorks. It's also a feature, just like Instant 3D, that you can toggle on and off. It's called dynamic highlight parent relations, something like that. We would search for it in a moment. But even if it's like a very, very big model with hundreds of features, you would still be able to see all of these, maybe not in the best way possible, but once again, it would indicate for you how these are linked to each other, what affects what in this visual way. So let's go back again into SolidWorks and see this in real time. If I want to activate something like this, I can simply right click on the top title of the feature or of the part, and over here you can see dynamic reference visualization parent or dynamic reference visualization child. You can also search for this. So if I hit dynamic, there it is. So here are the features, and if I click on this, it's going to indicate where I can, okay, I'm not doing anything, it's 100% it. So it's just now going to show, okay, here's the feature, here's the dynamic reference visualization, and here's where you can access it. So if you have it turned on, you can see once I select one of these, it now would indicate, okay, so boss extrusion, this is depending on the origin, it depends on the front plane, it also depends on its sketch, and it affects the cut extrusion. So this is its child. So if I right click and go to child, it's going to show the exact same thing. Here are its parents, here are its children. Okay, I can do the same thing with the sketch. If I click on the sketch, so here are its children, here are its parents, and so on. So very easily I can visualize the relationships and how these would affect each other. And if I would go into like a flat tree view, if I click Control T to go to this flat tree view, instead of having the boss extrusion and the cut extrusion linking the sketch underneath them, in this preview it's even easier to say, okay, this sketch is now identifying those and those. If I click on this one, it's now identifying those and those, and so on. You can very easily go ahead and see defines the position or the orientation or the value or the shape of the different other features as well. Okay, so now let's take it to the next level. Let's go ahead and look at segment 3. So segment 3 is the final segment of the CSWP, which might not be, depending on the order that you take them with. As I mentioned, you can take them in any order you prefer. But in this segment, we've already talked about part designing and modifications. We talked about designing based on other people's designs, modifying them, adding different configurations and modifying these in a single click. And then what's left is to do the same thing, but for for assemblies. I would love for it to include animation, but unfortunately this is only by assemblies. So segment 3 is all about making sure that what you have in terms of single part designs, when you combine them together in an assembly, your assembly is now functioning as you would expect it to. So with that comes a couple of things to consider. So the first thing is, where is your assembly? I understand it's inside of SOLIDWORKS, but the question is it on the front plane? Is it on the right plane? Is it on the top plane? Is it at the origin? Is it a bit far away from the origin? And if it is, where from the origin is it? So it's really important to identify where that assembly is in 3D space, because when it comes to a part, a single design, it's already going to be positioned around its own origin. The sketches will define where it is. But in an assembly space, well, I can put it pretty much wherever I would like it to be. I can drag a component and put it at the origin or far away from the origin, and then start assembling over there. So it's really important for me to specify where would I like that first component to be and build up based on that. Okay, so there are many ways to understand or specify where the origin goes. And the easiest way to do that is from the very first feature. Okay, so in assemblies we call them mates. So let's say, for example, you drag your very first component. Usually you would find that you're unable to modify where that component is. You can't move it, you can't rotate it, you can't change its position or its orientation. And this is because sometimes the components will be fixed. So if you go over here and go to the very first component you added to your assembly, you would find it's got this F symbol right before the name. You see that F between two brackets? So this is what is a shortcut for fixed, which means that just like the fixed mate or the, I think it's called the lock mate or the fixed relation, regardless of where it is in space, just stay where you are. That's what you're telling SOLIDWORKS. Just make sure that this component is here, regardless of what dimensions it's from the origin, what affects the other positions of the other components. Regardless of anything, just make sure it doesn't move and it remains how I left it. And maybe not the best option for a parametric model, which is why it's always good to right-click and float that feature. But there's actually a better way to do this, because if we go back again inside of SOLIDWORKS, so here I've got an assembly over here, okay? It's one of the assemblies in the built-in tutorials. Let's say I want to add a new component. So let me go and do insert components, okay? And it's going to now make me browse. Let's any component, maybe this base plate, for example, okay? And now I can click open, and if I add this component over here, I'm going to notice that it's going to be fixed. It's not going to be got any over here. And as you can see, I can click on it, I can move it, I can rotate it. It's totally fine. So what differs? What's different in this case that would make it easy for me to change the position and orientation of this component? Do you know? Because what it has to do is when I insert the component, there are certain settings that I would specify. Specifically right now, in front of you, you'd see these settings. Let me know if you know what I'm talking about down in the chat, because once again, it's very easy to modify every single component you add, but what's even easier is to change setting once, and then everything is already floated as soon as you add it inside of SOLIDWORKS. It's going to save you a lot of time when you see how many components you're going to add throughout your career. So let's see, has anyone noticed it yet? Okay, it's actually down here. You see this fixed / float on insert. So I think the default value is this one, only fix the first component. Some people would have it as fix everything, every single component that is inserted is going to be fixed. I would prefer to have it set to be float. Every single component is float. And then I can go ahead and say, okay, you see this first component, I can say where I would like this to be. Okay, so right now it's fixed. If I right click and do float, well, now I can move it. But the question is, where would I like it to go? And in this case, I would start adding mates. So maybe I would add a mate between the origin and the origin. Maybe I would specify the origin to be in a different place. Okay, I can see right now that the origin is not in the right orientation. So maybe I can do it with like the top plane and the right plane, the front plane and the top plane, and so on. So I can go ahead and say, okay, this front plane is with this top plane, and I would like these two to be together. Maybe I would like this right plane to be, I think, with this top plane. Yeah, the right plane with the top plane, and I will also these two to be together. And last but not least, let me just hide this one real quick. We don't need this. This right plane, let's make this with this front plane, and just like that, I can now make sure that everything is now fixed in its right position. Now, it's not fixed by just brute force, by telling it you there. It's actually fixed with mates. So now the table is now fully defined. You don't see these minus signs before it, and I can't hold it and move it around. You can see it says the selected component is fully defined, but it's now fully defined based on these mates that I've added, right? So it's very easy now if I want to modify something, to modify this mate or change it or update it and so on, based on how I would like it to function, okay? So now let's get back to how we started with this assembly. Once again, what we learned right now is that if I want to add a new component, make sure that it's specified in the position and orientation that you would like it to go through. And that's based on your mates, not fixing everything. And if it is fixed, as we saw over here, it's very simple to just right click and hit float. But what I would prefer is to specify a certain setting for all of your imports later on, so that as soon as you insert a component, it's already set to be float. Okay, let's see. So this is the first thing, to specify where the origin is. Okay, and even though we saw it together by doing it with 3 different coincident mates, in certain cases, if you have the front plane and the front plane of the parts and the assembly already aligned together, and maybe the right plane and the right plane, the top plane, all 3 axes are already aligned together, you can do this in one single row. There's just a single coincident mate between the origin of the assembly and the origin of the component. Only when you have 2 origins selected in the coincident mate, you would find this option, which is align axes. Okay, and what that does is, just as it says, it would align the x-axis for both of these, the y-axis for both of them, and the z-axis for both of them. So you would pretty much have 3 coincident mates in just one mate, where you just make sure that these 3 axes and these 3 axes are exactly aligned on top of each other. Okay, so it's not always going to work, because as we saw a bit earlier, sometimes you would have the origin in a flipped orientation. So in that case, you would have to do it manually. You would add 3 different mates. But as soon as you have that ready, you're now got everything in its position parametrically, not just by brute force. Okay, so we've got the first component. Now let's add the remaining components. Now these components can be 10, 15, 20 components, as many as they may be. But the main point here is to make sure that everything is connected correctly to each other. And this is where the mates would come into play. Because in the associate exam, I think it's only going to consider the standard mates, only like the coincidence, parallels, concentrics, distances, and so on. But now we're professionals. So we're now also going to be talking about the advanced mates as well. So make sure you go through these mates, because these are actually pretty cool mates to use. The profile center, if you've never used that before, this is a very, very cool mate to use. Maybe look it up in the online documentation help.solidworks.com, look for the profile center mate, because it's a very, very cool time-saving mate that would really make your assembling process much quicker. I also prefer the width mate. It's an amazing mate that makes it very, very easy to specify where your components are with respect to other components. And there are other mates here that you would also need to use to go through that exam. So make sure you're familiar with all of these. I'm just picking favorites over here. But once again, the standard mates and the advanced mates are what you would need to go through that exam. And now, maybe you've already went through these mates before, and you've even used the mechanical mates. Feel free to use that on the exam. But once again, what the exam is going to test you on is only the standard and advanced mates. If you use the mechanical mates, that's fine, but know that there's a simpler solution that would only use either standard or advanced or a mix of both. Okay, so once you have all of the components assembled together with the correct mates added and everything, now it's the best option for you to test everything. Just make sure that everything is where it should be and it works in the way it should go. So this is where the movement is important, because what I would do is I would just grab any component that's underdefined and start moving it around and see, is it moving in the way I would expect it to move in or not? And if it's not, what should I modify? Because if I go and look at something like this, I can rotate the handle and everything is working just fine. Okay, so that looks promising. If I go over here to my model, not this one, no thanks. So if I go over here to this assembly, it looks fine, right? But the moment I start dragging one of these components, okay, everything looks fine. Let's drag another component, maybe this one. And as you can see, I've already got a loose gasket. Okay, so moving these components around would give you more insights so as to what is missing. And this is the best way for you to determine the best course of action. What should I change? What should I add? What should I remove? Just to make sure that everything is set up correctly. Okay, so in this case, I see that I'm missing a mate maybe between this and this. Okay, and I'm also going to maybe do it. There are multiple ways to do it, but you can also use smart mates if you would like to. I'm just going to add like a very simple coincident mate. So just like that, now this part is correct. I can drag another component just to make sure that everything is working perfect. And just as I'm satisfied with the movement, now it's time to go to the next, which is, are you sure that this movement is correct? Let's give it a bit of a closer look. Can you see over there in that circle? You see that? Right now, that interference between these two bars. Now, the movement itself might look correct, but maybe the dimensions of the features, or maybe the positions of these components in the assemblies are not correct. So the movement as an overall movement is right, but based on the wrong dimensions or maybe the wrong positions of certain components, there is now interferences, intersections between these different components. And SOLIDWORKS as a software has no issue showing you these interfaces happening. It's not going to show you the collision between them as a physical collision unless you actually explicitly ask it to show that. So in this case, now takes you to the next level. Let's check for any interferences. Let's make sure that everything is working as it should. And it's really important for you to go through something like that, go through the process of detecting interferences, looking at the reports that come out of the interference and learning how you can modify these, how can you fix these, how you can identify exactly which components are interfering with each other, and based on that, taking the best course of action to modify it or to fix it or to change it, if that's what the question wants. So based on that, these are the different aspects that you should consider when going through the assemblies or for segment 3. Now let's take it to the last part, which is, let's understand, how can I tell the exam that what I've designed is what you would want? You want me to create this part, and I've created it. How can I prove to you that I've created it correctly? And this is where the extraction of information comes into play. You would show the model to the exam in terms of certain questions that it would ask you for. It might ask you for the mass. It might ask you for a certain length or a certain angle, maybe the center of mass, different things. So pretty much all of the different values that it's going to ask you for are going to be based on these two features over here. And both of them can be found in the Evaluate tab. Personally, I've removed most of these because I already have keyboard shortcuts for both of them, for the measure and the mass properties, as you saw a bit earlier. But once again, this is where you would find them. So let's start with the measure. And the measure tool is pretty cool. It's like the smart dimension on steroids, because what it would do is it would go ahead and based on what you would select, it would show you the different values that are predictable for that selection. If you select like two parallel lines, it's going to tell you the normal distance between them. If you select two lines at an angle, it's going to automatically tell you, okay, here's the angle between them. If you select two faces that are parallel, it's going to tell you the distance between them. Two intersecting faces, it's going to tell you the angle. If you just select a line, it's going to tell you the length. If you select multiple lines, it's going to tell you the total length, and so on. So without needing to specify what you're looking for, it's automatically going to show you those values based on what you selected. Now, if you select something generic, like a face, it's going to show you, okay, here's the surface area, here's the perimeter, and so on. It's all based on what you would select. But by the way, you don't even have to go through that feature every single time to extract that information, because once again, we're going to go back again to the status bar in the bottom right corner. And as you can see over here, it would actually show you some of those values straight away. So let's say, for example, you select two lines. It's going to show you the distance, the normal distance between them down there. If you select a single line, it's going to show you its length. If you select two faces, it's going to show you the distance between them or the angle between them, depending on their orientation, and so on. So in some cases, you don't actually need to open that feature. Just by selecting things in the graphics area, it's already going to show you that down there. And if you want to see something like that in action, here we are inside of SOLIDWORKS. Let's say, for example, I select this face. And if I rotate this model, select this face back here, okay, as you can see down here, it says the normal distance is 416.49 millimeters. I didn't need to launch the measure tool. It just told me, I can select this face, and it's also going to tell me, okay, the angle between them is 119. I didn't need to say that I'm looking for an angle. It automatically understood that this is the value that you're looking for. If I, let's say, select this line and this, okay, the angle between them is 90. If I remove this line, it's just going to tell me the length of this, 254, and so on. So based on your selection, it's automatically going to show you the value that you're looking for. Okay, now that's with the measurement tool. But not everything is extractable through the measure tool. So we also would need the mass properties tool. So what the mass property would do is it would simply show you the values are based on the mass. So if you add a material, and that material obviously would have a density value accompanied or along with it. So let's say if it's aluminum, or if it's steel, or if it's different types of steel, it would have different properties, which include the different densities. And if you have all the dimensions correct, that would mean that the volume of the model is correct. And if you have the material set correctly, that would mean that you have the density correct. So if you have the density and you have the volume, you can now divide them by each other and now obtain the mass. And the mass is going to be the value that the question would mostly ask you for. So in that case, as long as you've specified the correct material and you've designed everything according to the right dimensions, which relates to the volume, now you can 100% be certain that you've got the correct mass. Okay, and it would also be important for the center of mass. And when it comes to the center of mass, it's not only about the materials and volumes and density and stuff, but it's also about the reference. Because when I say that the center of mass is like x equals 5, y equals 2, and z equals -20, according to what? 5 centimeters from where? -20 in which relation? Is it to the origin? Is it to another reference? I don't know. So this is where the positioning of the assembly is really important, and not just the positioning, but also the reference that you're using in the mass properties dialog box is also important. So maybe the question would say, okay, instead of referencing to the origin, I would like it to reference this point in space, this coordinate system that you would create, and so on. So it's really important to make sure that you've created all of these correctly. You understand how to do those, and you will also understand how you can change the reference value that it tells you from the origin to another coordinate system, and so on. Once you've got all of that ready, you've got nothing to worry about, because as long as the model is ready, you've got the volume right, and you've got the mass correct, which means that the density is also set correctly, you've got everything you need to pass the exam. And just like that, you can now go ahead with these 3 main takeaways. The first thing is your answers has to be as close as possible. I need the question to be answered in like 2 decimal places, then only do it in 2 decimal places. Don't do it in 1. Don't do it with no decimal places. It's actually looking for those values. And once again, for the CSWP, for the professional level exam, it's only 0.5% of an error gap or an error window to work with. The other thing is not to make any assumptions. Don't do anything based on what you would expect it to do. Only base your references along the data that's presented to you, and that data is going to be through the dimensions, not the images, because these images have variables in them, A, B, C, and A and B and C can change from one question to the other, but they're not going to change every single image just for your sake. So in that case, if you take a screenshot maybe of your model and just overline it on top of the images in the model that in the question, it's not 100% going to be correct because certain variables are given at a different value. So in that case, make sure that you follow the dimensions that are presented to you, not the lookalike of the model exactly. Okay, so with these 3 things, you are now ready to take the CSWP exam, and hopefully you will all pass it with 100% score. Now, let's take a quick break and see the tester in action. Okay, so let me see real quick. Let me know in the chat how many of you have taken exams before. How many of you have already taken an exam on the virtual tester? And if you have never taken an exam before, also let me know down in the chat. Because what we're going to do now is we are going to first go and see how would I even take an exam in the first place. And it's also really important to see which account would I use. Am I going to use my student account or my personal account? If I work for a company, am I going to use my work account, and so on. So the first thing I'm going to do is I'm going to go to this website. Okay, so this website is 3dexperience.virtualtester.com. Don't worry, I'm going to put all of these links in the chat after I finish. So I see there are many CSWA holders in the chat, which is cool. So you're already pretty familiar with this. When you go to this website, you just click over here to download the virtual tester. And then when you download it, you will have a file that you would run, and it will give you these 2. You have the exe file, the Tangix tester software itself, what we call the virtual tester, and this library files, which we're not really interested in. Now, one main thing is that every single time you launch this software, you would have a new log file created. This logs everything. So let's say, for example, you know what? Let me even show it to you. So right now, let me just exit it, okay, and let's launch it once again. When I do that, I'm going to have another log file. Okay, so what this log file does is it's now saving all of the actions that I do, all of the details of what I'm doing, just in case anything bad happens. Let's say, for example, your internet connection fails, or your computer crashes, or SOLIDWORKS crashes, or any issue might occur. It's really important to have these log files with you, because if you're reaching out to the support team, to the SOLIDWORKS certification team, they would probably ask you for those log files to attach as well, just to make sure that they can verify what you're claiming. Okay, so it's really important to look at these log files. Now, obviously, you need internet to take an exam. I don't need to tell you that. But the cool thing is, it's the same account for pretty much all of the different brands of exams you're taking. Now, if you haven't created an account yet, I can see that already most of them have already created and even taking exams as well. I can see this the CSWP in the chat as well. Cool. I would prefer if you would create an account on the website, not over here. So if you would create the website, the account on the 3D Experience Center, it's going to be the same account for both of them, for that website and for this application. But when you create an account, you still have to go through your email and click on a link to verify it, and then set up your password and stuff. So it's not like you're going to create an account in the virtual test, not the exam. You still need to verify your account. So I would prefer if you would create your account first and then download the software and take the exam. Either way, just make sure you accept this option over here, list in online directory of certain users, and I'm going to mention why in just a moment. Anyways, I already have an account, so let me just I missed a point here. And please look the other way while I enter my password. Just kidding. So once you log in with your account, you will now find the different brands that you can take an exam for. So let's say, for example, you're going to take the CSWP. I don't have it ready because I've already taken the exam, so it's not going to see, but maybe CSWP Professional. So if you have the start exam button, that means that you already have a voucher or access to that exam. You can just click on it, choose the language, and start the exam just like that. Obviously, I'm not going to take it in front of you, but this is how you would start any exam. Now, if you don't have access to the exam, if you click on it, it's going to take you to the website to purchase that exam as well. So either way, this is how you would start pretty much anyone. But the main thing here is, which I mentioned a bit earlier, once you do this, regardless of what exam you take, as soon as you finish the exam, you can now go over here and log in and go to your account, and you would find a list of your exams or your certifications. So my CSWP is over here. I can now download the certificate, download the badges. I've got this QR code anyone can scan to verify my exam. And I can also see this code over here, the certificate ID. Both this and the QR code will be at the bottom right, left corner of your certificate either way. But you can take these codes, and if you go over here to this validate certificate, I can enter it. I can enter these numbers, 68, and now it's going to wait, what? 186. Oh, let's try a different one. Okay. Just a moment. Yeah. So as soon as you verify these numbers, it's going to validate that exam over that certificate for you. It's going to tell you, okay, this is taken by someone called Yahya, whoever that is. It's a CAD professional exam, certified SOLIDWORKS professional. It was taken on that date, and it's validated today, just to make sure that this is up to date. Okay, so this is the way you can validate pretty much anyone's exam worldwide, just to make sure that, okay, is this certificate real or not? Okay, but the real value here is to go over here to the certified users directory. Now, remember that checkbox, that option that I mentioned? Well, it's over here. This is the real value behind it. Because if you don't check that option, which you can also find if you go over here to your account and go under your settings, you can also find the same thing. So if you don't check that, when we go ahead and search for certified users, you won't find you. We will not find you at all because you've hidden yourself. So let's say, for example, we want to see the certified users in the professional level. So we can see we've got 276,000 certified professionals worldwide out of 8 million users. That's a big number. So you're now putting yourself ahead of others, okay, which is a good thing. Now let's see in Uganda, how many professionals do we have? So this is a good example because we have 28 certified professionals in Uganda, but only 13 are listed over here. The remaining 15 are certified professionals, but we can't find them on this website. So they've opted to train or hide themselves, so no one can reach them. No one can know that they're certified. And the real value here is that someone will go ahead and say, okay, we're looking to hire a new designer, and we need him to be in this city, so we can search by the city or something, and we can see, okay, this person, let's see, he's certified in all of these things, contact information, so I can reach out to him on LinkedIn and say, hey, would you like to work for us or stuff like that. But if he's not listed here, I would not be able to reach out to him. And if he's listed but he doesn't have his contact information, I would also not be able to contact him and reach out to him. So it's really important, because this is a better way for you to present yourself to others, to have your contact details over here. You don't have to put everything, just your preferred ones, maybe your email, your YouTube channel if you have one, Facebook, LinkedIn. I would prefer LinkedIn, and make sure that you're actually decided to showcase yourself here, because once you do that, anyone can now see your validated skills and see that you're actually someone they can approach and reach out to. Okay, so with that out of the way, we are now ready to go through the last portion of our session today, which is the references. Okay, so once again, these are all going to be the free resources that I've used. There are obviously many paid resources out there, but these are the main ones that I have already tested myself, and these helped me greatly get certified back when I took my CSWP. And the first thing is obviously the built-in tutorials inside of SolidWorks. You know, these built-in tutorials, I keep mentioning how important and how valuable they are. So if you have never used them before, let's go over here to start SolidWorks, and just close this real quick. So you go over here to the help menu, okay, and click on tutorials. It's, what's that? Let me just fix this in a moment. Yep, here it is. Okay, let me just adjust this. So here's the built-in tutorials, just because I'm using multiple screens, just getting out of the way. But let's say, for example, I want to do a design on fillets, for example, or maybe I want to design, want to learn something about mouse gestures. I want to add some keyboard shortcuts. I want to learn more about customizing SOLIDWORKS. I can learn things about equations. I can learn things about mold design. There are different topics that are covered here pretty well, actually, and I would really ask you guys to use these, because these are really cool tutorials to go through, and there are many benefits to these. We start by mentioning that they are free. They come with your license. Every license includes these. They're offline. You don't need an internet connection to use them. Oh, this is the cool thing. So let's say, for example, I want to take this fillets class, okay? So I need to apply the lesson on this part file. Now, I've got two options here. I can go ahead and go through these steps and create this model, okay? So it's going to tell me, okay, do this, do that, do that, do that. Or I'm just here to learn fillets. So I can click here, and it's automatically going to open that model inside of SOLIDWORKS. You see this link to have all of these sample files already available and ready to you. But you want to see the even cooler thing? Let's say it says here to click the fillet tool, okay? But I'm not sure where the fillet tool is. I can click here inside of the tutorial. I'm not doing anything, but inside of SOLIDWORKS, it's now highlighting where that feature is. So it's so cool to be able to have this interconnection between these tutorials and SOLIDWORKS as a software as well. Okay, so one more cool thing is that, let me just go back again. So you see this title, CSWP and A preparation. It lists all of the different topics that you would find interesting and you would preferably need to go through before you take the exam. So some of these are a bit basic. Some of these are a bit higher than you would need. So you won't need sheet metal, for example, for the CSWP, but assembly nature or multi-body parts, that's going to be something you would prefer to learn. So so feel free to go through these at your own pace, but remember, these are pretty cool tutorials, and I would always recommend anyone to go through these. Now, the next thing on my list is My SOLIDWORKS. Now, My SOLIDWORKS is a website for pretty much everything SOLIDWORKS. Okay, so it even says that over here, your place for all things SOLIDWORKS. You know, you can search for CAD models over here. Instead of going to grab CAD or 3D Content Central or anything, you can search for these directly over here. You can search for the SOLIDWORKS user forum from here, or as we're going to do right now, we can filter by training and search for, let's say, CSWP. I want to look for tutorials for the CSWP. So if I filter by learning paths, I can see that there are an exam preparation course. There's the sample exams being solved here. Once again, the sample exam that we mentioned earlier. So you can go through these. Let's say let's check the preparation course, and you can see here the different videos that you can go through to learn about that exam, to prepare yourself for the CSWP. Okay, I'm not sure why it's taking some time, but anyways, these are available to anyone who has a license of SOLIDWORKS. You already have access to My SOLIDWORKS as part of your subscription. So we've got all of these different videos that you can go through to learn about global variables, learn about the rib feature, planes and points and axes and different reference geometry and so on. So it's all divided by different topics. Each is like a short video that you can go through and understand and make sure that by the end of this whole learning path, you're ready to take the exam as soon as you make sure that you apply pretty much all of these different features, okay? Now, the last thing is the sample exam, which is something we mentioned a bit earlier. So remember the PDF that we could download from the website, from the solidworks.com/CSWP website? Well, here it is. It's a PDF that is pretty much explaining everything that you would need to go through before the exam, while you're taking the exam, and after the exam, but it also has some questions for you to test yourself and make sure that you're ready for the exam. So here it says, okay, the exam is like segment 1 is this long, segment 2 is this long, and so on, how many points you would need to pass, what topics it's discussing, and so on. So we already saw this information on the website. Okay, here it tells you, okay, how to take the exam, to download the software. We've already seen this. Now, here is the sample exam itself. So here are the questions. So here are test questions for you to test yourself, make sure that you understand the style of the exam, how it would look like, how would you ask you different questions. So for example, here are the images, here are the different types of dimensions, here are the global variables that I mentioned, A and B and C and so on. Okay, here's the question. So it tells you the units, the decimal places, the origin if you would need it, the material, and so on. You've got the global variables. Here's the question itself, design this, do that, and so on. And then here are the 4 choices. But remember, only for the first question would give you choices, because after that, it's going to say, okay, do some modifications, change these global variables, do anything, and then tell me what the value is. It's not going to give you choices, just tell me what the value is. Enter a value, and it has to be within 5%, 0.5% of the correct answer. Okay, here it's going to say, okay, you know what, let's now add this fillet over here, let's add this pocket, change this, change that, and so on. And then at the very end, tell me what the new results are going to be. Okay, and at the very end over here, you're going to see it's got the answer key, the answers to all of these different questions that you just went through. So this is a sample exam for the first segment. We only have a sample exam for segment 1, but I would prefer for you to actually take this exam in the virtual tester, not from this PDF, because that would mean that you would have the whole experience of taking an exam, especially if you're taking it for the first time. You have the timer, you have the question, you have SOLIDWORKS, you can now switch from this to that, and so on. So you're putting yourself in the scenario of taking a real exam. Okay, so you're better preparing yourself. And if we go back again to the PDF, at the very end, you've got some tips and tricks. You've got some frequently asked questions. So things like, what should I do if the internet connection failed? Or if my computer crashes, what can I do? And stuff like that. So it's a good read for you to go through these and just understand what you should do in these different cases. All right. Now, the last thing is a shameless plug to Journey to the Search. So in case you don't know, I have a series of articles that I've written quite a while ago, and they're all compiled in this link. I'm also going to share it in the chat in a moment. So I've got a separate article for every single one of the CAD design series of exams. So everything from the CSWA, the associate level, all the way to the expert, along with all the 5 different professional advanced exams. So that obviously includes the CSWP. So if you go over here, you will find this LinkedIn article where you can find pretty much like a summary of what we discussed today, but in a written text form, if that's what you would prefer. So if you prefer going through this information as text, well, you can go ahead and check it out. So here's, for example, the different types of taking the exam, 3 different segments or 1 full 3-hour, 20 minutes exam. Here's segment 1, segment 2, different tips and tricks that I share along the way. You will also find some resources that I mentioned, obviously mentioning the tutorials at the beginning. And here, for example, is also the sample exam that I mentioned. Okay, so if you take the sample exams, obviously going to be free from the Tangix tester. That would be preferable because it would give you a better understanding of the experience or the style of the exam. And there's also some general tips and tricks at the end, how to do some customizations, add keyboard shortcuts, stuff like that. So it's really helpful if you want like a reminder of what we went through in this session. Okay, so once again, I'm going to put all of these links in the chat in a moment. But before I finish, let me just say that I'm going to now check all of your questions. We've already finished our session for today. It's now time for a Q&A. So feel free to put your questions in the Q&A section. I'm also going to check the chat for any questions that I missed throughout the session. What's really important is that, let's say, for example, I miss any of your questions, and hopefully I will not, or if you have any questions in the future, feel free to share them with me on my LinkedIn. I've got an open profile. Anyone can reach out to me through a message. So you can scan this QR code. I'm also going to put my link in the chat. It doesn't even have a question. If you take the exam, if you take the CSWP and pass it, I would love for you to post post the certificate on LinkedIn, tag me, tag Uganda SWUG, tag its leaders, and let us know. Let us all celebrate your certificate. So with that out of the way, I'm going to now put the links in the chat, and then while I do that, feel free to add your questions in the Q&A section.
Yes, thank you, Yahya, for the wonderful session so far. It has been a session that captures mind and the tricks behind the CSWP. Those are the three segments. Yeah, so for the questions within the chat, I tried to copy them and drop them in the Q&A. You can just go in the Q&A. I have dropped some of the questions that were in the chat.
Great. I'm going to check them out in a moment as soon as I finish checking out these links. Okay. I think this is the last link. All right. All of the links are now in the chat. Feel free to check them out. So here in the Q&A, let's see. So Tanvir is saying, I have difficulty finding dimension. Any advice? I'm not sure what you mean by finding a dimension. Are you talking about finding the value of the dimension from the exam questions, or are you talking about the feature, the smart dimension feature inside of SOLIDWORKS? If you could please clarify, that would be great. There's another question here that says, talk about design tables a bit more. You know, the thing is, design tables, these are the ways that you would easily create and modify configurations. So if you have a design of maybe the block that we created earlier today, that block with its whole, with the dimensions and everything, you can create multiple versions through configurations. But instead of going one by one and configuring each feature, you can create a table where you have, here's the length, here's the width, here's the diameter of the hole, here's the width of the hole, here's the position of the hole in X, Y, and Z directions. And then all you have to do is just enter variables, enter the values. Okay, configuration 1, here are the values. Configuration 2, here are the values. And all of these values will be saved in this design table. You will have this table that is going to be much easier for you to manage and control all of your configurations. So there are many different ways to approach design tables inside of SOLIDWORKS. SOLIDWORKS recently added something called configuration tables. So you can do this table directly inside of SOLIDWORKS. I think that was in 2024, if I'm not mistaken. If you're using an earlier version, design tables were created through Excel. So you need a license of Microsoft Excel on your device. And then when you click on the design table, it would open Microsoft Excel inside of SOLIDWORKS, and you would see the different table cells, and you can add different values, or you can add different features to suppress them, unsuppress them, change the values, and so on. So I would suggest you would check out different sessions out there for design tables. There are many actually that can be like a whole session on its own, just to how to create design tables, how to manage them, tips and tricks about these. I'm sure there are many on YouTube as well. I would prefer if you would go to the tutorials built in sort of SOLIDWORKS. There's one or two tutorials down there that specifically talk about design tables. So you can start by these, and if you still have any questions, you can check out the recordings of the sessions on YouTube. And if you still have any other questions, feel free to reach out to me. I would be more than happy to help you with any issues that you may have. Okay. What else do we have? So the question about instant 3D, we talked about that. Just search for it in the feature manager design chain, just click on it. That's going to be turned on or off. Just toggle on or off. Okay. Abdul Aziz is saying, what's SOLIDWORKS PDF? I've seen it in the previous slide. I think you're mentioning the sample exam, right? So let me also put that link in the chat. So if you go to solidworks.com, okay, /CSWP, that would basically take you directly to the CSWP website, which we saw a bit earlier. And from there, you can download that PDF, that whole PDF that we went through. Okay, so in that way, you can go through the sample exam questions. You can learn a bit more about the exam, how long it is, what topics do I need to understand, and also the FAQ we saw at the end with different scenarios of if this happens, what to do, if that happens, what to do, and so on. Okay, let's see what other questions we have. Okay, so we have a question here as well. It says, a friend of mine offering electrical engineering asked if these certifications are available for the PCB and electrical part of the software. So SOLIDWORKS PCB was discontinued in 2018, so we no longer offer SOLIDWORKS PCB anymore. But we have SOLIDWORKS Electrical, and there is an electrical exam. It's not really a hands-on exam. It's just a multiple choice question. It's an associate level exam. So there is a CSWA in electrical design, but it's very basic. So I would not really consider it of high value in the market. But it does exist. So if he's interested in being certified in that area, so yeah, if he uses SOLIDWORKS Electrical, whether it's schematic or 3D, he can go ahead and take the CSWA Electrical Design exam. Okay, he can look that up. But that's not going to talk about electronic design, only electrical design. So no PCB, no IC design, nothing like that. Okay. We have another question here from Jason. He's saying, I was wondering what would be the best way to get a CSWP voucher. I'm a student studying engineering and would like to get certified. My school doesn't offer it. Okay, so we have multiple scenarios here. Since you already ruled out your university or your school offering it for you, if you purchase a student license of SOLIDWORKS, that would come with a voucher for the CSWA and the CSWP for free with the license. So with the license, I think it's like $60 or something like that for a whole year. Okay, it's the latest release of SOLIDWORKS, and it's SOLIDWORKS Premium, which is the highest package or offer of SOLIDWORKS. But will also come with two vouchers, one for the CSWA Associate and the Professional, which on their own they're $200. So you're getting the software and the exams for just $60, which is obviously a very good offer. And if you would like, feel free to reach out to me on LinkedIn. I can give you also a 50% discount on the price of the student edition. If you're still a student, you can make use of that discount as well. Okay, so that would be one way. You can also look out for different events that would happen. So 3D Experience World, which is going to be next February, it has a very cool thing which, if you've traveled to the event, anyone can sign up for free exams. You can take any exam there for free. Even the CSWE, the expert exam, it's also available there for free as long as you're qualified for it. So that's one way. There are other events that happen along the year that you can go through. For example, you also have SWUG 10, which is going to be next month. Okay, so I'm also going to put the link to that in the chat. So SWUG 10 or SWUG X, as I should say. Okay, so SWUG is the SOLIDWORKS largest user group meeting ever. It's something we do every single year, and who knows, there might be some giveaways, there might be some vouchers, I don't know, but it's going to be a very cool gathering of SOLIDWORKS users and enthusiasts like us, discussing design, discussing different, showcasing different projects that were created using SOLIDWORKS. So I would really encourage you all to sign up for it. It's going to be a YouTube live stream, and it's going to be on the 6th of November, if I'm not mistaken. So make sure to check that out as well. So these are like the main ways to get certified if you're still a student. Okay, if you actually work for a company that has a license of SOLIDWORKS on subscription, not only do you get access to my SOLIDWORKS standard subscription, which we provide you with all the courses that we just show a bit earlier. There's like 110 courses for free for you on my SOLIDWORKS, but you can also get access to up to 3 free vouchers every 6 months. So in 1 year, every single license of SOLIDWORKS on subscription will give you 6 free vouchers for SOLIDWORKS exams. These can be anything from associate to professional advanced. So you have 29 different exams to choose from. Everything is open except for the CSWE, the expert in CAD design and expert in simulation. Other than that, all of the exams are available to you for free. So if you work for a company that provides you with something like that, with a license of SOLIDWORKS, you can reach out to your reseller if you don't know the procedure, but you can get up to 3 vouchers for free for every single license on subscription. Okay. What else is there? We have a question here from Shariri saying, when do we use functions? I think you're talking about equations, if I'm not mistaken. It all comes down to, do you want this to be linked to something else or not? If you want it to be linked, then in that case, you need to add that intelligence to the design. You need to tell SOLIDWORKS that this value is not just a discrete number. I'm not going to enter 100 or 200 or 150. I'm actually going to link it to something else. I can link it to another value. I can link it to an equation of multiple values added together, multiplied together, divided by each other. It can be anything. So as you saw at the beginning of the session, when we had that 100 dimension in width, and we wanted to position the hole at the third of the height, what we could do with the third of the width, we could do it with multiple ways. When we did it with dimensions, if we just enter 100 divided by 3, not an equation, just a value, SOLIDWORKS is going to calculate 33.33 and put the dimension. But if I change the 100, it's not going to change the 33. So if I want these to be linked together, I want to add that intelligence to SOLIDWORKS, I now need to do an equation. I now need to say, okay, if this value changes, then that value changes. And this is through an equation. I would add an equation. If I need a global variable, that's fine. If I don't need, as we saw also, we don't need to use that. That's already fine. So I can now say, okay, this value is equal to that value times 2 divided by 2 divided by 3, whatever it is. It can be plus 1, whatever. But the main thing is I'm now linking two values together. If one changes, that's going to affect the other, just like we saw with the child and parent relations. Okay. Let's see what other questions we have. I think we've covered them all, if I'm not mistaken. Let me see. Yeah, I think I've covered all of the questions. Once again, if you still have any questions for me that I haven't answered, feel free to put them in the chat. We still have like a minute or two. And if in the future you have any questions for me, here's my LinkedIn on the screen. I also put the link in the chat. Feel free to reach out. I can help you out with not just SOLIDWORKS questions about the CSWP, but anything that you might have in mind. I would make sure to reach out. But please let me know your feedback as well. And if you take the exam and pass it, also I would be more than happy to be tagged or mentioned in your posts to hear more about your story of how you passed the CSWP. And with that, I think we are ready to sum this up.
Thank you, Yahya, for the great session and tips that you have shared in this session. For me, however much I got my CSWP sometime back, but I have gained the real tricks that I missed sometime back. So in the same way, I believe also members, they have gained tricks and tips. For example, the inbuilt videos, by then for me tutorials, I never used any of them. So it has been a great session, and thanks for always accepting my or our invitations as SWUG leaders to come and share the information you have to the young generation, engineers, creators, and innovators. It has been a wonderful session. Thank you, members who have joined in today, and we are looking forward for other more sessions. Yeah, some were asking about the certification. This event, we are not offering certifications. Yeah, we are just preparing members for the certifications. So it has been a great day. Thank you all. Nice time.
Thanks for the kind words, and it's my pleasure. I would love to see all of these members that we have in this session. We're approaching 40 members certified soon. So good luck with the tips and tricks, and see you soon.
Bye bye. I will share the session recording on the YouTube channel. Next time you can leave the session at any time of your wish.